Here's how you might deal with residual analysis from a regression procedure. So suppose I have this medical data set, and I have a couple of continuous variables, gluc and hemo, say. And so that's my model statement is gluc equals hemo, the y variable is the x variable, and my output data set contains the residuals, the predicted values, and the studentized residuals, in other words, the z-scores of the residuals. And so the thing to keep in mind here is that that data set, that output data set, really does contain all of those variables in it. So when I go and print it out, I end up with all of the variables that I had in the original data set, race, age group, and so on, gluc among them, as well as those predicted values, the residuals and the R-studentized residuals that I just created. So when I want to play with those values, maybe make QQ plots, I just need to think in the back of my head that really is a data set, and those variables really are in there. So that's what I'm going to do is I'm going to go ahead and use this plot and say plot the studentized residuals by the predictor variable and plot them against the predicted values. So you can just kind of see if your assumptions are met, see if you have a good scatter. There's against the predicted values, and that's against the original predictor variable, which is the main plot that most people use. And you can also do things like one popular recommendation was to take the residuals and take the square root of the absolute value of those residuals. I'm going to just use the studentized residuals, and I'm going to call this variable my new y's, and to plot those against the predictor variable. So I'm going to plot data equals more against the y's against the predictor variable, which is hemo. So now I can create this new plot real quickly like that, because I'm keeping in the back of my head that those studentized residuals are in a data set, and I can manipulate that data set however I want to. Apparently the idea in doing this square root of the absolute value was to reduce some skewness. In the absolute value. So another thing you can do if you want, like, say, QQ plots and you want to test for normality of the residuals, is you can go in here and do a proc univariate. And I did normal, so that should give me some normal analysis. I did not put plots in here. If you want a QQ plot from the univariate procedure, you can do that. You can put plots, but I didn't do that right here. And so you can figure this out. The Shapiro-Wilk is the usual p-value for normality, and you can see the p-value is 0.5, so that looks good. Our stuff looks normal. And then you can run this proc capability to get, say, a really nice QQ plot. If you use this QQ plot in the univariate procedure, what you would end up with, if you put the plots option here, is you would end up with a line plot in the output over here. But if you want that pretty plot, you can use this proc capability, and it'll give this nicer plot out here.